Sources of energy. Introduction. Energy is a critical factor in our daily lives. The resources from which the required energy is harvested, known as sources of energy. Our success depends on our ability to develop energy sources that are plentiful, renewable, and environmentally sound. A good source of energy is that which is capable of providing sufficient and safe energy at a steady rate over a long period of time. In this chapter, we shall be dealing with conventional and non-conventional sources of energy. Objectives. In this chapter, we shall learn about the following concepts. 1. Good source of energy. 2. Conventional source of energy, which includes A. Fossil fuels, B. Thermal power, C. Hydropower plants, D. Biomass, E. Wind energy. 3. Non-conventional sources of energy, under which we study A. Solar energy, B. Tidal energy, C. Wave energy, D. Ocean thermal energy, E. Geothermal energy, F. Nuclear energy. 4. Environmental consequences. 5. Longevity of energy sources. Let us begin our session by analyzing what a good source of energy is. The muscular energy used for carrying out physical work, electrical energy used for running various appliances, chemical energy used for cooking food or running a vehicle all come from some source. So, how do we select the source needed for obtaining the energy in its usable form? Well, the sources that we select to perform a particular work depends on different factors. For example, while selecting a fuel, we want the fuel to have characteristics like availability, economic feasibility, combustibility, high calorific value. Hence, a good source of energy should have the following characteristics. It should do a large amount of work per unit mass or volume. This means that the output energy must be more than the input energy. It should have a high calorific value. It should be easily accessible. That is, the energy source should be able to provide energy over a long period of time. Example, coal and petroleum. Should be easy to store and transport. Most common sources of energy such as coal, petrol and LPG need to be transported to users from their points of production. They also need proper storage, thus it is important to store and transport these sources safely and economically. Should be safe and convenient to use as it is used by a large number of people and should be convenient. Example, nuclear energy from a nuclear power plant is hazardous to be used at homes. It should be economical. It should be eco-friendly. We shall now look into conventional sources of energy. The sources which have been in use since a long time are called as conventional sources of energy. Petroleum, natural gas, coal, wind energy and nuclear energy are some examples of conventional sources of energy. They are also called non-renewable sources of energy. We shall now explore some of the conventional sources individually. Firstly, fossil fuels. Fossil fuels are formed millions of years ago, when plants and animal remains got buried under the earth and were subjected to high temperature and pressure conditions. Example, coal, petroleum, etc. So, why do we need to conserve fossil fuels? Well, the fossil fuels are non-renewable sources of energy, so we need to conserve them. If we were to continue consuming these sources at such alarming rates, we would soon run out of energy. Now, what are the disadvantages of fossil fuels? Well, the burning of fossil fuels leads to pollution. The oxides of carbon, nitrogen, and sulfur that are released on burning fossil fuels are acidic oxides. These lead to acid rain, which affects our water and soil resources. So, the next question is, how do we reduce the pollution caused by burning fossil fuels? Well, the pollution caused by burning fossil fuels can be somewhat reduced by increasing the efficiency of the combustion process and using various techniques to reduce the escape of harmful gases and ashes into the surroundings. Let us now check our understanding. Question: fuel formed under the Earth's surface by the decomposition of organic matter is called? Option A, organic fuel. Option B, biogas. Option C, fossil fuel. Option D, underground fuel. The correct answer is option C, fossil fuel. We shall now see the process of thermoelectric production. For this, we make use of turbines. The simplest turbines have one moving part, that is, a rotor blade assembly. The moving fluid acts on the blades to spin them and impart energy to the rotor. Thus, we see that basically we need to move the fan, the rotor blade, with speed, which would turn the shaft of the dynamo and convert the mechanical energy into electrical energy. We shall now look into the thermal power plant. A thermal power plant is the most conventional method of generating electric power with reasonably high efficiency. It uses coal as the primary fuel to boil the water available to superheated steam for driving the steam turbine. The steam turbine is then mechanically coupled to an alternator rotor, the rotation of which results in the generation of electric power. Let us now check our understanding. Question: fuel used in thermal power plants is option A, water, option B, uranium, option C, biomass, option D, coal. The correct answer is option D, coal. We shall now move on to hydropower plants. Idle energy is produced by utilizing the kinetic energy of flowing water. Huge dams are built over a source of water. Water is collected behind the dam and released. When the water falls on the turbine moves because of the kinetic energy of water. Thus, electricity is generated by the turbine. Electricity thus generated is called tidal energy or hydroelectricity. Since the water in the reservoir would be refilled each time it rains, it would not have to worry about hydroelectricity sources getting used up the way fossil fuels would get finished one day. We shall now look into the problems encountered during construction of dams. Building large dams is not good for the ecosystem. When a large dam is built, a vast tract of land in its vicinity gets submerged. This destroys a large part of vegetation and wildlife, which does immense damage to the ecosystem. When the submerged vegetation decomposes, it produces a huge amount of methane gas. Methane is a potential greenhouse gas and thus is not good for the environment. Building large dams also affects a huge section of the population which lives in the surrounding areas. Many villages need to be evacuated, although the government comes with some rehabilitation plan for them, but the displacement of people from their roots has its own costs involved. Let us now check our understanding. Question 1. Which method is used to produce electricity in hydroelectric power plant? Option A. Production of steam by boiling water. Option B. Ionizing water to turn the turbines. Option C. Utilizing the kinetic energy of flowing water to turn the turbines. Option D. None of the above. The correct answer is option C. Utilizing the kinetic energy of flowing water to turn the turbines. Question 2. The power plant which converts potential energy of falling water into electricity is Option A. Nuclear plant. Option B. Thermal plant. Option C. Hydropower plant. Option D. Wind plant. The correct answer is option C. Hydropower plant. Moving on, we shall now discuss the improvements in the technology for using conventional sources of energy, which includes biomass. The plants and animals constitute the biomass. Firewood from plants is used as kitchen fuel. Farm waste such as stalks of harvested plants and dung of cattle can be used to generate methane. The decomposition of biomass produces methane, which can be channelized for useful purposes. These fuels do not produce much heat on burning, and a lot of smoke is given out when they are burned. Therefore, technological inputs to improve the efficiency of these fuels are necessary. When wood is burnt in a limited supply of oxygen, water, and volatile materials present in it get removed and charcoal is left behind as the residue. Charcoal burns without flames, is comparatively smokeless, and has a higher heat generation efficiency. We shall now explore the functioning of a biogas plant. The plant has a dome-like structure built with bricks. A slurry of cow dung and water is made in the mixing tank from where it is fed into the digester. The digester is a sealed chamber in which there is no oxygen. Anaerobic microorganisms that do not require oxygen decompose or break down complex compounds of the cow dung slurry. It takes a few days for the decomposition process to be complete and generate gases like methane, carbon dioxide, hydrogen, and hydrogen sulfide. The biogas is stored in the gas tank above the digester, from which they are drawn through pipes for use. We shall now discuss its advantages. Biogas is an excellent fuel as it contains up to 75% methane. It burns without smoke, leaves no residue like ash in wood, charcoal and coal burning. Its heating capacity is high. Biogas is also used for lighting. The slurry left behind is removed periodically and used as an excellent manure rich in nitrogen and phosphorus. The large-scale utilization of bio-waste and sewage material provides a safe and efficient method of waste disposal besides supplying energy and manure. Let us now check our understanding. Question: which of the following is a component of biogas? Option A. Methane. Option B. LPG. Option C. CNG. Option D. Hydrogen sulfide. The correct answer is option A. Methane. We shall now move on to the next source of energy, which is wind energy. Unequal heating of the landmass and water bodies by solar radiation generates air movement and causes winds to blow. This kinetic energy of the wind can be used to do work. This energy was harnessed by windmills in the past to do mechanical work. For example, in a water lifting pump, the rotatory motion of windmill is utilized to lift water from a well. We shall now see how wind energy is harnessed to produce electricity. Wind energy is used to generate electricity. A windmill essentially consists of a structure similar to a large electric fan that is erected at some height on a rigid support. To generate electricity, the rotatory motion of the windmill is used to turn the turbine of the electric generator. The output of a single windmill is quite small and cannot be used for commercial purposes. Therefore, a number of windmills are erected over a large area, which is known as wind energy farm. The energy output of each windmill in a farm is coupled together to get electricity on a commercial scale. Wind energy is an environment-friendly and efficient source of renewable energy. It requires no recurring expenses for the production of electricity. What are limitations faced while harnessing wind energy from windmills? The limitations of wind energy include, firstly, selecting the right place. The wind energy farms can be established only at those places where wind blows for the greater part of a year. The wind speed should also be higher than 15 km per hour to maintain the required speed of the turbine. Establishment of wind energy farms requires large area of land. For a 1 megawatt generator, the farm needs about 2 hectares of land. Secondly, availability of backup facilities. There should be some backup facilities like storage cells to take care of the energy needs during a period when there is no wind. Thirdly, economic efficiency. The initial cost of establishment of the farm is quite high. Moreover, since the tower and blades are exposed to the vagaries of nature like rain, sun, storm, and cyclone, they need a high level of maintenance.